Hi, this is Dr. Gregory Sadler. I'm a professor of philosophy and the president and founder of an educational consulting company called Reason.io, where we put philosophy into practice. I've studied and taught philosophy for over 20 years, and I find that many people run into difficulties reading classic philosophical texts. Sometimes it's the way things are said or how the text is structured. But the concepts themselves are not always that complicated, and that's where I come in. To help students and lifelong learners, I've been producing longer lecture videos and posting them to YouTube. Many viewers say they find them useful. What you're currently watching is part of a new series of shorter videos, each of them focused on one core concept from an important philosophical text. I hope you find it useful as well. Immanuel Kant, in the Prolegomena to any future metaphysics, in the first part of the Transcendental question, which is concerned with how pure mathematics is possible, is going to spend a lot more time talking about examples from and inferences that we can draw about geometry than he is going to talk about arithmetic or mechanics or any of that. And you might say, well, why is that the case? Well, Kant seems to think that it's really important to focus on space as one of the forms of intuition. It is also itself an a priori intuition. And we find that he tells us that pure mathematics, which is synthetic cognition a priori, so it's cognition, erkenntnis, that puts additional things together. It's not merely analytic. And it is a priori, so it has necessity, apodicity, universality to it. He says it's possible only by referring to no other objects, and objects there is not Objekte, but Gegenstände, things that we actually take as objects, but those of the senses, the Sinne, right, the multiple forms of sensibility that we have. And this kind of goes against, a lot of theories of mathematics that view mathematics as something kind of special. It deals with an ideal realm of numbers. And then, when it comes to geometry, we have to figure out, okay, well, how does geometry connect up to what we often call the real world? We call the world of appearances or phenomena or representations, right? The world in which we do experience time and space and things in them. So he tells us that there is an a priori pure intuition at the basis of empirical intuition. What is that? Well, we've talked about this elsewhere. The forms of intuition, namely time and space, which are there before we even have things in time or space. And he tells us that, this intuition doesn't represent things as they are in themselves, but as they have to be for us. And so he says, my intuition contains nothing but the form of sensibility, which in me as a subject precedes all the actual impressions through which I'm affected by objects. Okay, so far, so good. Now, geometry tells us is based on the pure intuition of space, not time. Arithmetic is based on time. And then we have this other thing, pure mechanics, which we don't need to worry about, because he only uses a few examples of this, although one of them shows up in the many examples that he uses for geometry. And so he tells us, this is in section 12, in order to add something by way of illustration and confirmation, we need only watch the ordinary and unavoidably necessary procedure of geometers, people who are engaging in geometry, whether they're teachers or researchers or students who are learning it. And he says, all proofs of the complete congruence of two given figures. So if you've taken a geometry class, you know that congruence is a very important idea. And what does it mean? It means essentially that one is exchangeable for the other when it comes to figures. And how do you know this? You can superimpose one onto the other and you don't get any surplus, any place where one doesn't overlap with the other. This means that you can substitute one for the other. And Kant is going to say This is a synthetic proposition. Okay, so a proposition that's teaching us something new, resting on immediate intuition. Okay, so far so good. Immediate intuition, you're looking at stuff. Aha, but it's not intuition that is empirical of our experience. He says this is an intuition which is a priori, pure and a priori. Otherwise, we wouldn't have it being apodeictically certain in every case. We could say, well, we've done these tests a lot with taking figures and imposing them on each other, and it looks like in all of the cases we've seen so far, no, that doesn't get you universality. That doesn't get you necessity. That has what he calls empirical certainty only. In that case, it could only be said, it is always found to be so and holds good as far as our perception reaches. And Kant says, well, that's not what geometry is actually promising or claiming to us. Geometry is saying, hey, if you do things like proofs in geometry, you get knowledge you can take as absolutely certain, right? So that's an interesting discussion there. And then he gives you a whole bunch of other examples. Now, some of these may be more controversial than others. Kant claims space can have only 3 dimensions. Now, he might be wrong about that. There's other alternative models of space that say that there are more. But anyways, he's going to say complete space has 3 dimensions, and that space in general cannot have more is based on what? Based on the proposition that no more than 3 lines can intersect a point at right angles. So, visualize this to yourself. You have, a single line going through a point. You've got 1 dimension. You've got another line bisecting it at a right angle, 90-degree angle. Now you've actually got the XY plane. And now you do a third one going through. And now we have a 3rd dimension. And can you put any more in? No, because you're not going to get any more right angles, at least in geometry as we typically think of it and as we experience the world. So Kant is saying you can't just sit in your, let's use that old locution, ivory tower or armchair and, think to yourself, how many dimensions should I give to space? You actually have to think about how things come together, but you're doing so not by carrying out some sort of empirical experiment. You are doing this in your mind and thinking about the conditions for the possibility of space as we know it. And he says this proposition cannot be shown from concepts, but rests immediately on intuition. And so you might say, oh, it rests on intuition. We do something empirical with this. Nope. Once again, this is pure intuition a priori because it's apodeictically certain. So it's the intuition of space itself as a form for empirical intuition. He also talks about another example, the infinite continuation of a line. You never actually do see an infinite line in the space that we inhabit, right? Because it's infinite. The fact that it doesn't end would mean you can't see that endlessness, can you? Or, he says, a series of changes, for example, space is traversed by motion, that these are infinitely continued presupposes a representation, a Vorstellung, right, of, now notice what he says, space and time. So here we're dealing with not just geometry, but also pure mechanics, at least with the changes. The line, okay, that could be pure geometry, but now it's no longer a pure intuition of space as the form of empirical intuition. It is a, let's say, fuller intuition at its basis of both space and time coming together in a certain way. That turns out to be the same in every case and for every rational being. So geometry is illustrating by unpacking these examples that we really are working with something that is the form of sensibility for us. And then he says, those who cannot rid themselves of the notion that space and time are actual qualities inherent in things themselves, inherent in the nature of the universe, may exercise their acumen on the following paradox. And he's actually going to give 3 different examples of this paradox. First one is a little bit hard to visualize. He talks about spherical triangles, that is, triangles that are inscribed within a sphere. So he says, here we go. If 2 things are quite equal in all respects, as much as can be ascertained by all means possible, quantitatively and qualitatively, it must follow that the one in all cases and under all circumstances must be able to replace the other, and the substitution would not occasion the least recognizable difference. So this is the congruence that we were talking about earlier. But we have, with sided, we could call them figures, incongruence between them. So he says, this is true of plane figures in geometry, but some spherical figures exhibit, notwithstanding a complete internal agreement, a difference in their external relation that the one figure cannot be put in the place of the other. So they're not congruent. So 2 spherical triangles on opposite hemispheres, which have an arc of the equator as their common base, may be quite equal as regards their sides and angles, but the one cannot be put in the place of the other on the opposite hemisphere. So you've got a sphere, and you could take these triangles and you could actually flip one around, and if they were just an empty space by itself, they're congruent. But you can't do that on the place in the sphere because it's not going to fit. And so we're going to see what this reveals to us in just a second. He's got another great example of your 2 hands. He says you don't have to necessarily do geometry. You can look at your everyday experience. What can be more similar in every respect, in every part, more alike to my hand and my ear than not the other hand, but their image in a mirror, right? Because you could say, well, this hand over here has got different proportions than this one. This is my dominant hand. I'm actually semi-ambidextrous, so my dominant hand isn't that much more dominant. But some people have big right hands and smaller left hands, or vice versa, right? Not that. Mirror image. So you got this hand, and then you've got it flipped around in a mirror. Or we might use a selfie, or we might use whatever else we want to reverse it. So he says, if this is a right hand, then in the mirror, it's a left hand, right? And the image or reflection of the right ear is a left one. And these can never serve as a substitute for the other. There are no internal differences, which our understanding could determine by thinking alone, but the differences are internal as the senses. Sensibility teaches us, for notwithstanding their complete equality and similarity, how do you know they're not the same? The left hand cannot be enclosed in the same bound as the right one. They're not congruent. And what's a very common way of understanding this? You can't use your left glove on your right hand, right? Whereas you could perhaps with some other body parts. Similarly, if you had like a nice container for your ear, you can't simply put the left one in the right one or on the right one. And so he says, there's one other one that we could consider. He mentions this just in passing, opposing winding helixes. So a helix is a spiraling figure that isn't just a spiral in one dimension, but in 2 dimensions rather, but in 3 dimensions, right? So think of the DNA helix, right? You can have a helix and it's got a certain kind of spin to it, we could say. Well, you can flip it around and it's not the same helix anymore. How do you know that these aren't completely interchangeable with each other? So Kant says these objects are not representations, Vorstellungen, of things as they are in themselves and as some pure understanding would cognize them. They are sensuous intuitions, that is, appearances, Erscheinungen, whose possibility rests on the relation of certain things unknown in themselves to something else, namely to our sensibility. So he says space is the form of the external intuition of this sensibility. And this is a really important thing he's going to tell us, right? Spaces that we can look at, see, sense, right? Spaces, or the internal determination of any space, is only possible by the determination of its external relation to the whole, the entirety of space. So even though we never take in the entirety of space, we are, you could say, placing the things that we sense as representations within that total space. Now that's an interesting observation to make. He says, in other words, by its relation to external sense, the part is possible only through the whole, which is never the case with things in themselves as objects of the mere understanding, but can be the case with appearances. So all the empirical representations or appearances that we are taking in through our senses are arranged in the entirety of space, which we intuit a priori as a whole, but as the form of sensibility. Now, there's a very important implication of this that Kant is going to draw out in Remark 1. So he says, pure mathematics, especially pure geometry, can only have objective reality on condition it refers merely to objects of sense. But the principle holds good that our sense representation is not a representation of things in themselves, but the way they appear to us. So it follows that the propositions of geometry, expressing geometry as a science, are not mere creations of our poetic imagination, which could not be referred to assurance with actual objects. So geometry is not a kind of made-up, ideal discipline. Nothing in reality really fits geometry. As a matter of fact, it's the other way around for Kant. He goes on and he says that the propositions of geometry are necessarily valid of space, and consequently of all that may be found in space. That means everything that we grasp through our senses in space as representations or appearances is handled by geometry. So he says, because space is nothing but the form of external appearances, and it is this form alone in which objects of sense can be given to us, so the appearances can never contain anything but what geometry prescribes to them. This means that geometry is yielding us knowledge a priori of everything potentially that could be experienced by us in space, and perhaps, with certain extensions, in time as well. So this, which may be contestable, is a very important point that Kant is making here about the nature of geometry itself and why geometry works the way it does, why it has, as he calls it, its apodictic certainty or necessity.